Okay, I probably should have added this in the other video, but it was getting really long. So here's the last couple examples. So referring back to what's listed as page 129, although these are kind of mixed up, we have this function that we were working with, the parabola that we cut in half to make it 1-to-1. We figured out its inverse right here. Now we're going to check to see if that's accurate. We want to compose g with g inverse of x and see if we get x. And make sure you clearly mark the domain. Okay, so I rewrote that right here so we can just reference it easily. So we're going to put the inverse inside the original. So we would have negative square root x plus 4 plus 2 squared minus 4 times negative x plus 4 plus 2. Okay, and now we are going to expand this out. It gets a little bit messy there. It's a perfect square trinomial, so we know like these, the product of these will double. And we have this square of the first one. So the square of the first one would just be x negative square root of x plus 4 times negative square root of x plus 4 would just give us x plus 4. Then if I multiply these two together, negative square root of x plus 4 times 2, right? And then double it, I would get minus 4 square root of x plus 4. And then square the last one. So I get plus 4. Now here, I'm going to distribute, so I get a plus 4 from those negative times a negative, square root of x plus 4, and then a minus 8. So now we can look and cancel some stuff out. So we have this minus 4 times the radical plus 4 times the radical, so that goes to 0. I have a 4 and a 4 make 8. So minus 8, I can get rid of those. Those will go to 0, and I'm left with x. But remember, it's not just any x. It has to be x greater than or equal to negative 4 so that we're restricted and have a proper function. The next one is doing the reverse. We're taking the composition, we're doing g inverse of the original one. So you could try that one on your own. You could pause if you want. But let's see, I'm going to go through it. So we're going to pop the inside here into x in our function. So we would have x squared. So we're going to write negative square root of x squared minus 4x plus 4, like that, and then plus 2. So that works out kind of nicely. So I can really just remove the parentheses there, and then I have my perfect square trinomial, right? So I can write this as negative x minus 2 squared plus 2. Then I would end up with negative, take the square root of that, I get negative x minus 2 We really want to make sure we're careful here. X has to be less than or equal to 2 for this one. So we're going to take it as the absolute value. It's the negative of the absolute value of x minus 2 when we take that out. Plus 2. So whatever's in here, this is actually going to be the absolute value. So we will end up with these two crossing out. So we'll end up with a x minus 2, and then that will give us an x. X less than or equal to 2. So that one's kind of tricky to think about solving that out. Okay, for number 6, I'm going to change this to say m of t because instead of p, because down here part C references m. So let's just change that. And then we'll be good to go. Because there's less of the p's. So what we're going to do is state the domain of the function m of t. So we have square root of 3 minus t plus 2. So we have to make sure this is greater than or equal to 0. So my domain would be t less than or equal to 3. To make that work, just set it equal to 0. Then we're going to find the inverse and state its domain. So again, we're just going to do the switching thing. So try that one on your own and see if you can get that to work. Okay, so here's the answer for that. You can check your steps against mine, and the domain has to be greater than or equal to 2, because if I had to have this, I can kind of look at the range on my original to figure out the domain on the inverse. So no matter what I put in for this t, I would have to have 0 or bigger, right? Because this has to be 0 or bigger. So I'm always going to get something greater than or equal to 2, because my range here was y has to be greater than or equal to 2. So I know that has to be my domain here. And then my range is going to be the same as my domain in the original. Okay. We also have to think about, like, as this is a quadratic, we have to pick one side or another. But that's how we know this side. So for part C, doing a lot of different compositions. So we're looking at m inverse of 4 in the inner function. So if we figured out m inverse of 4, we would put 4 into our inverse, and we would get 4, let's see, we would have negative 4 minus 2 squared plus 3, so that would be a 2 squared, so that would be minus 4 plus 3, and I would get a negative 1. So this becomes negative 1 in here. Then I would take my negative 1 and put it into my function above. So I would get square root of 3 minus 1 plus 2. That would be 4, square root of 4 plus 2, which would end up being 4. So I actually get my 4 back. So that works really well. If I have a negative 1 in here, what do you think it's going to be? Is that going to work for m inverse of m of -1. I should get -1. So you could check that. You do, in fact, get -1, and that one works. But what about here when I'm trying to put the 4, I do m inverse of m of 4. Do you think that one's going to work? What will happen? So let's look over here. M of 4, I have to look at what the domain of my original function is. I can't plug in anything. Where is that here? T has to be less than or equal to 3, right? So I can't plug a 4 in. This is going to be does not exist or undefined. And now here for the inner function m inverse of 1, if I'm trying to plug a 1 into my inverse, that's going to be a problem because I have to have everything greater than 2. So this one does not exist. So just watch for that. Make sure it's in the domain. So I had the 4 to start with, and this top one is greater than or equal to 2, so that will work. The second one, remember, I have to look at the domain of the inner function. It works. It fits the bill, so it's okay. But on these, if I can't start right, it's not going to work. It's not in the domain. I have to write does not exist. All right, so I hope you find that helpful. Let me know if you have any questions, and I will get back to you on that. Or if you want to do a Zoom connection or something, let me know. Have a great day.